do the Make 10 strategy and the children have practiced it. We don't test them on it. It just gives us a way to communicate clearer. Because people are strolling in, I'm going to go through, if you look at the front page of your packet, I have listened, and parents want support. I am putting together, and it's called a binder. It doesn't matter, but I'm putting a place together that's going to house these videos. It will have a copy of this this packet. It will have whatever else I think you could use. And it'll have a copy of your teacher's strategy letters per unit. I've only got one thing up on it, so it's not worth us going to it and seeing it, but it's there, and by the end of the week, this should be up there, a copy of this, and all of that. So I just want to let you know. I know it's a ghastly address. There's nothing I can really do about that, but once you put it in once, if you have any trouble, just email me, and then I can email it to you, and then it's easy. So that's just an FYI. Let's get started. We are now, your kids, it's about halfway through the year. We're going to go through this. Remember, this is about a 6-week class for them, and we're doing it in an hour. So it's going to, I will be honest, it will feel disjointed. It will feel very fast. It is. But I'm trying just to show you the strategies so that you can understand them. I'll be glad to take questions. At some point, I may say, let's us talk afterwards, if it's for the majority of people need to keep going. So I'm going to go through and chunk it in the order that your kids are learning it. So please don't go home and go to the last strategy and say, let's try this one tonight, because they need to learn them in order. It is a progression, and that was one of the brilliant things the new standards did, is they really told us how to teach them in order so that the knowledge with the kids builds. First page, as I said, lots of vocabulary. Compose and decompose, fancy words. First graders actually like them. They learn to Tyrannosaurus Rex. They can learn compose and decompose. Again, we don't test them on it, but we use the language, but we also scaffold it by saying put together and take apart. That's what they mean. Place value. In first grade, they've moved from beyond 10, so they need to understand the 10s and the 1s. They've already started. We're going up to 40 now, so they're understanding 10s and 1s. Number or numeral form, unit form. This is an important one that's fairly new. Do they understand that it's 34 is 3 10s and 4 1s, not a 3 and a 4? So again, we're giving them the language so they can explain their thinking. Make 10 is a strategy that you'll see in a little bit. Addition sentence. In adult world, that's an equation, but they are starting to write those. Greater than, less than, and equal to. At the end of this packet, we are not going to get there. Greater than, less than, and equal to, the concept is not particularly difficult. It's remembering which direction the signs go is what's difficult. We show them how to draw it. So I gave you some pages at the end, but I doubt that we're going to have time to get to them. But I wanted to show you what we do. And there's the alligator mouth. He's really hungry. The open alligator mouth always goes to the big number. There are a few other strategies for remembering it, but that's really the most difficult. And then lower on there are pictures of the different strategies. Your children have been using number bonds since the beginning of the year. Number bonds is the philosophy of part, whole. We can represent any number in part, whole. In this particular unit, we are going to break numbers apart by their place value. So 34, I would break apart into a 30 and a 4. At other times, we might break it into 32 and 2. For this unit, that's about place value, for 6-year-olds, we're breaking it apart by place value. We have the place value chart, so they understand that it's 3 10s and 4 1s. Quick 10. This is just a way of quickly drawing what you're building. we do not want the kids leaving first grade walking around with Unifix cubes in their pockets. Manipulatives are always good when we're learning a new concept, but we do take them beyond manipulatives. We teach them how to draw it. We teach them how to start visualizing it in their head, seeing the patterns, and that's when they move towards just the algorithms. Arrowway is just a notation. This is a great way of a child who can do it in their head being able to write it down quickly to show me what they were thinking. And lastly, the tape diagram. Tape diagram, I'll just say it, is the American word for, I'll get the other word out of my head and I'm forgetting it, the bar model. They are the identical things. Teachers are having trouble switching back and forth because we called it bar model for several years. Now it's a tape diagram. Tape diagrams are especially useful for figuring out what a word problem means. But they are also part whole, so they are also very related to this. And kids quickly figure out, if you have two of the pieces of information, you can figure out the third. So learning how to take a word problem and putting it into a tape diagram is how we help them understand word problems. So that's the quick overview. The beginning of this unit, your children have probably already done this, but this is the refreshing of the place value. Do they see that tens and ones are different? Can they look at a picture, and at first they may be counting them up, but then they get used to this idea, oh, the tens place is where I put those bundles of tens. So in this first one, they would probably count, there are 10 in this great cluster, there is another 10, well that's 20, that's 10 and 20, and then I have 7 more. So how many total would that be? 27. And this is, they probably did it last unit, but it is a new concept in first grade, this idea that we can write the numbers that way. So this page is about practicing math. We're starting to bundle them so they can see them and trust that they're tens. So how many tens are there? There are 3 tens with 2 ones. I mentioned before, for this unit, our number bond, we are using place value. How many tens are there? So how many would that be? 30. How many do we have? And so our total would be? Would you just go ahead and do the rest? Or do one? I don't mean to insult you, but I do want you to see what the kids are going through. I'm trying to show you it in all the different ways that they see it. Oh, I sent you off and then I see that there's a, so what do we have? Let me do them in order. Oh, purposely. They can be broken apart. And this is the organization of our numbers. How does our place value work? Oh, well there's 3 tens. And is that 9? Now we go, we're moving away. For 6-year-olds, this is getting more abstract. So now I have 3 tens and 5 ones. Tens. I want to highlight this one. In the olden days, we didn't care so much that kids could recognize this, we just wanted 24. We now know that that's a flexibility that good mathematicians and good mental math people have, that flexibility to think of it both ways, because when we can break it apart, we can do things easily in our head. I'm going to highlight this one also, the fact that we know that 2 tens and 7 ones, we could build it, but I could also take them apart and I could have 27 ones. That flexibility of being able to go back and forth is important. We used to think, oh, once you learned it, it kind of got left behind and we moved on and it was better to move on always. Now we know there were a lot of people secretly in their brains breaking it apart and doing that and not telling anybody that they were getting the right answers quickly. And the rest of us were writing it down and following the algorithm. The last one I put on here to show you a sideways number bond. Number bonds can go any way. It's part whole. It could look like this. It is still part whole. It can be circles. So we're not really picky on the picture. It's the idea that we're representing the two parts and the whole.
So what's the difference? Sorry, what's the difference on the third and fourth picture?
These two?
Yeah, these two. What's the difference?
We grouped all the 10s together, so it matched this. Where this one, they were scattered all over. It doesn't matter. It's still 3 10s.
So you still
And
like
the ones.
3 10s and 9 1s, that'll be 3. That's how they
Yeah.
get it.
Yeah.
Still like the same as
And now, mind you, we would be doing this with the manipulatives first, and any child struggling would probably take these 3 and put them together to see them.
What do you mean it should be? They should be 3 or 30.
It should be 30, right?
Oh, I see what you're saying. That was my mistake in the writing, I'm sorry.
Okay.
Missed the question. And the reason also we show them this is because this could start to be an addition problem. Although I think you were questioning my mistake, huh?
No. Pushing the difference.
Yeah. So that although our writing and our place value has a direct pattern, we can rearrange these things any way to meet our needs, but then we write it out in our place value pattern. Any other questions? A major standard in first grade is to be able to add or subtract by 1 mentally and add and subtract by 10. So 8 plus 1 is 9, 28 plus 1 is 29. It's that adding on and counting back. It should become something that they get very comfortable with. So that is part of this unit. We want to show them what are the two parts here, 19 and 10. What is the whole? 29. There were 2 10s, 9 1s. And what we hope that they start seeing is that as we're subtracting this, they're seeing that the pattern of, oh, I could talk about this as 2 10s and 9 1s. If I add 1 more 10, well, that's 3 10s and 9 1s. And that can become a mental skill, not something that they have to write down and or draw. If they're still drawing, honestly, they're not going to the mental skill yet, and that's fine. We'll do it some more, and they'll get used to it, and they'll be able to start visualizing. So 20 plus 14.
Did you say if they're still drawing, then?
We draw some more? I'm sorry, I didn't see.
Did you just say that if they were still drawing, they didn't have mental? Or what did you just say?
If a child's still building it, they need, the building is what's going to get them to the mental understanding.
Just do it.
Yeah, so if they can't do the mental, we go back to the drawing. If they can't do the drawing, we're starting with the manipulatives. Then we're going to the drawing. Then from the drawing, we're going to something like this. It's the representation, but it's more abstract. But we don't ever just say, sit down and memorize this. You know, that 29 plus 10, or 2. If they're not understanding that 2 10s plus, let me get there, 1 10 plus 1 more 10 is 2 10s, we need to be building it some more. The brain research is really, really big on the word yet. They may not have it yet. They will get it. We just have to meet their needs of where they're at in their learning. But these are the pages, and I'll be honest, they seem a little bit cumbersome when they come home to you. You didn't build them in class with them. So that's just what I'm trying to show you of what they're doing in class. So we've got this answer that it's 2 10s and 4 1, except that it's 3 10s. And 4 1s, then we start seeing the relationship of we write that number as 34.
How did they get the 3 10s? Did they write the whole thing down into a pen?
That possibly, this would be, if they can't see this, we would do 10 and 4. Yeah. There's also room here. I would probably having 20. Yeah, and this is quite a spectrum. Some kids are going to see it immediately, and some kids, if they're not seeing that, I think I would go to the drawing before I would go here. As I said, the progression, now that they're understanding this is a way to write down what are they doing in their head if they're understanding it. If they're saying, oh, 13 plus 10, well, I know that that's 13 equals, no, I shouldn't say equals. I want to be specific about the arrow way. It can keep going multiple times, and that's why we don't use the word equals. This could be, do my plus 10 first, that would equal 23. I'm going to do my plus 4 next, that equals 27. I can say equal at the very end, but 13 to 23 to 27, those are not equal numbers. So there's language we're trying out. 13 plus 10 gets me to 23, plus 4 gets me to 27. But this is for when you're thinking. You've got the flexibility to be doing it in your head, but somebody's asking you to explain your thinking. There's lots of ways to do this problem. And because we want them understanding it, we're asking them all different parts of this arrow way. So if I'm getting from 19 to 39, what am I adding? I had plus 10 and I got to 27. This is the same type of question. So these 2 pages are just more especially to explain what the directions are you might be seeing. I asked you to have your manipulatives. Could you go ahead and grab them? And I'd like you to build what we're seeing here, this 22 plus 6. So 22, if possible, in one color. With the children, we'd be very, very specific. They would have enough colors. With this many people, I had to hope that it would work. If you don't have enough colors, work with your partner. So the 22 should be in one color, and the 6 should be in another. Being the place value unit, we are building them in groups of 10s. So as we are building with the double digits, we are building them using the base 10 system. So we start off with 2 10s and 2 1s. We've added 6 1s. It's very visual. At this point, the kids are counting, or another lovely math word is by supertizing, which means you're able to look at a number and know it without counting, which up to 6 is about as far as most people supertize easily. So they can see that this is 22 plus 6. What did they get? They got 28. How many 10s do I have total? 2, and I have a total of 8 1s. Several days have gone on. We've done this quite a bit. It gets tedious building them. So we start teaching them how to draw quick 10s. First time we draw a quick 10, we have this sitting right there. If we don't think back to yesterday, remember that problem, we have the problem sitting there. Well, if we don't want to build it, how could we draw it quickly? Well, I have a 10 and a 10 and 4 ones that match it. I have 3 more. So although I don't have color, I'm using symbols to show it. So this would be 24 plus 3 equals 27. And I can see my 2 10s and my 7 1s. Now I'm going to be honest. We have 7 different teachers. Can I guarantee that they're using dots and X's? No. Are they probably using dots and X's? Yes. If your child uses X's and then dots, is that okay? Yes. If your child uses a smiley face and then a star, is that okay? It's okay if it's not interfering. If they are drawing the most gorgeous smiley face, like this, and then just have a perfect smile and 2 eyes and hair, you've just moved into art. On the other hand, if they just find this fun, go for it. Back to the stars. It's an age where kids like to learn how to do stars. If they've mastered it and they can whip them off, great. If they're struggling and then erasing it because it's wrong, now's not the time, but we can do that after homework. So we do the representations to represent the math, not the art. Would you go ahead and do 5 and 6? You're welcome to do 3 and 4. I just don't really think you need to. Some of us are still at the building and then drawing stage. Some of us are just straight to the drawing stage. In the math class, manipulatives will be at the desks all the time. So if Tommy's not getting it, we don't make him go walk across the classroom in front of everybody and pull them out and all the other kids start laughing. The manipulatives are just part of it. And, in fact, I would say often we have as much issue of breaking the kids out of the habit of using it. It's like, but you drew that first. You really don't need to build it. But we want to keep them as a positive resource. So these problems, I'm not sure if you noticed, they were selected to not go over 10. They may have gone up to the next 10, but they didn't regroup. Again, it makes a difference in the classroom teaching. After they're comfortable with that and they're going it, they may not have mastered. That's okay, we can move on. We're still going to be revisiting these ideas. But we're going to move on to making 10 or above. So if I have 15, you know what, I'm going to go to the second one as an example. 15 is just showing you, the first one's just showing you how to get to 10. The second one is going above and beyond. We're building it the same way. We see that we have 2 10s and 1 1. The answer is 21. The only difference in this is when we got this 5 and 5, we actually made a mark through our drawing to show that it makes a 10. So you can see where if I haven't quite mastered the day before, the lesson before, this one's fine. I'm not doing anything that much different. And I can still be very successful with this drawing. So making 10 really just means that I mentally note, oh, it has completed another 10, and I'm moving on to the extra ones. But we're being specific about it, not just saying, oh, it's just another number. Would you go ahead and just do one of the other ones? Yeah.
So you did struggle with that drawing the line for the negative 10. I mean, like tally marks versus, right? It's very obvious whenever you hit 5 and then a 10. But this, if they're drawing the dots and the X's odd sizes, maybe they're writing 12 and it's the same length as the line.
Are you asking, are we talking about a hand-eye coordination thing? Or an understanding?
That's part of it, but,
yeah.
you know, I mean, as an example, is I'm wondering if kids are counting while they're drawing the dots and X's, or if they're using the visual reference, the line next to it.
I think if they're using the line next to it, we would need to address that. Most of them don't. Is there going to be a child who does it? Probably. But no, you're right. They're not going to have, at first grade, those lines are not going to be beautiful and neat. And if they're really struggling with numbers, you know, you're saying it could kind of look like, I mean, especially 28, could be all over the place.
Yeah.
If I were the teacher in this, and this is normal, and this is where the child is, you know, I'd probably have them just loop the 10. Again, it's actually more the idea that it's now become a solid 10, as opposed to having that straight line. I might also pull out a highlighter so they can just make the line and understand the representation. And that is an issue. I don't think most kids are adding as they go along. I mean, we're building it and they're separate and then we're putting them together. And if a child is adding as we go along, they're probably not the ones having trouble.
So when do you stop the use of the cubes, the manipulatives, when you go into a full abstract ability?
There will be kids in first grade that will be adding this. We go back to manipulatives every time it's a new concept. Will we take this concept onto just numbers? Yes. We will in this unit. But it's just not at the beginning of the unit.
Okay.
Now, it may not be the algorithm you're thinking of. I mean, if you're talking, when do they do?
Yeah, when they stop using the cubes, when they use only their brain.
When
College?
they're-
I'm being serious. My husband is a 7th grade math teacher. They use cubes for the algebraic expressions. At the beginning of every new concept, we do it. With each concept, we move on to the abstract. But when a new concept comes along, we go back to the cubes. Most first graders by the end of first grade will be adding 2-digit numbers definitely without cubes, most of them without pictures. But then next year, in 2nd grade, when they get into 3-digit, they're going back. 3-digit, we do the cubes maybe once or twice. Cubes become really inefficient at some point. But we will go back to the picture in the 2nd grade. 5th grade, area model for multiplication, back to the cubes, and so they will. Let's finish. I think you'll see where we're going. But it's not going to be to this. Yes?
When you're doing 28 plus 4, I get you have your 2 lines. And when you start doing the ones, when you're drawing the picture, you've got 8 circles, we'll say. And then you need to add 4 more. How do they know when they hit 10 on that 3rd line and need to go to a 4th line? Does that make sense?
Okay, then that might have been related. We would get them stopped when they've done 28. And what do you need to add? 4 more. To begin with, and I'm sorry, I was just trying to be crazy, so I created a problem. I might do my 4 over here, and then circle them and put them over here.
Okay.
That would be a very first step, but kids very quickly will tell me, but I could have just put 2 over there. Because parents, your children should know their math facts up to 10 inside and out.
So you stop at 28 and then you think, okay, how many more do we need to get to 10? You have 4, you draw the 2 and then the other 2. So you kind of stop and reevaluate after
Right.
28, I guess.
Yeah.
Okay.
And at the very beginning, that's what we would do. We've got 28, we've got 4 more, what should we do? And the kids will tell me, finish out the 10. How many does it take? 2. So they're not highly thinking of, oh, I took the 4 and split it into 2 and 2 yet. They're just finishing their 10. We've got 2 more.
What about, for example, if they did 8, then the 28, and then they did a 4 separately, and then whatever, join them together, like so.
Yeah, and you'll start seeing, you know, that oh, I'm going to put the 2 over here, and especially if they're doing
Circle
it.
the 10 group together,
Yeah, any way they want to circle it. And
as long as it makes sense.
yeah, and knowing as the teacher that this isn't where we're staying, If they want to draw the circle and put it over here, or if you said if they wanted to do this, I'm going to accept that. This is about understanding it. So it's not, I don't want to say it doesn't have to be neat and pretty, but that child is showing me, oh, I understand these ones are going together as a 10, and then I have some more. So they've shown me that they understand that.
But it really helps if they draw neat, because when they scribble and the line with the one is longer than the line with the 10, and it's still 10, they might think, oh, this is a longer line. Yeah.
And I can encourage it all we want, but we've got kids who don't have the fine motor skills yet to do that. And the kids, those fine motor skills develop pretty differently. Now, if I saw the child with these very different ones, all I would say is, I'm going to be careful about my numbers here. I would have said, oh, look at your drawing and look at what I have. Could you make it better? And you know, that's about as much as I'm going to force it. And what they're doing here is they're really seeing this pattern of the numbers matching, that 2 10s and 1 1 is 21. And so this is where they get it at this part of the unit. So we've shown them how to do it. We're not worrying about mastery at an abstract level. And then we go into word problems. Yes?
Sorry, one more quick question. You were saying language matters, so the phrase you were using is it's regrouping the 10?
Regrouping, composing. One of the words used is recomposing. I think we're starting to push it there. I mean, we're putting together. I'm trying to think of the old-fashioned word for subtraction, the borrowing, we don't use. For addition, most of the words still work. Borrowing doesn't work because we're not borrowing. We never get it back. We're not trading back, so that's why we've gotten rid of that. Literally, because kids were too literal. It's like, when are we going to give it back? Okay, we're trading. We're regrouping. There's become a definition of mathematics. Mathematics is knowing how to solve the problems in the world. We were doing a really good job of teaching computation before. Computation's excellent. You need to know how to do it. But if you don't know what it applies to, it's actually fairly useless. If you go into a grocery store and you look at 2 cans and you don't know that you have to add the 2 prices together to get the total, it doesn't matter if you can add 3 plus 4. So that is why you are seeing far more word problems. It's not just ASD. It is the Common Core, understanding that we need to be mathematicians, we need to be problem solvers, we have computers, we have calculators. We've got to understand what to do. So sometimes the language takes help. We need to give them help, especially most of our kids here are ESL, they're learning English as a second language. We try to keep them simple. If your child ever comes home with a question about that, obviously you try to translate it or you make it into something they know. That's not the issue, but what we don't want you to do is just pulling out the numbers for them. It's the idea they need to understand the problem. And that's where the tape diagrams are for. Tape diagrams show that you're comprehending the problem. So this says Lee saw 6 squashes and 7 pumpkins growing in his garden. How many vegetables did he see in his garden? Tape diagrams are always this long skinny rectangle. It's a little bit they can be converted to a number line later, is why. This doesn't matter. I could say, okay, I can see, or I understand that there were 6 squashes. We do start labeling. To understand a problem, we need to know what's what. I'm not going to make a child write out squash. If they understand an S is for squash, that's fine. And then he saw 7 pumpkins. Now the label is, what am I asking for? And I drew too close to my top. As I mentioned, this is like our number bond of the part, whole. I have a part, I have another part. My question is, how many do I have total? Well, I've got 6, 7, 8, 9, 10, and 3 more. we saw 13 altogether. And I caught 6 lizards. And I demonstrated something wrong here. Don't draw the rectangle first. Start drawing the numbers, because this is classic where the child will draw a really small rectangle and things won't fit in it. As an adult, I'm used to my own habits. So 6 lizards. My brother caught 6 snakes. Okay, here's our lizards. Here's our snakes. This is the same type problem. And 12 reptiles in all. Nine dogs in a park. Some more dogs came in. How many am I going to draw? I don't know. So I'm going to put a question mark. Then there were 11 dogs. Well, I know how many total. You just set up your problem. Dogs in park. So now it's not an addition problem or a subtraction problem, it's how are you going to solve it? And you're welcome, the different kids will solve it different ways. So we've gotten away from saying, oh, you have to use addition, or you have to use subtraction. Well, you don't have to use subtraction, you can count up. The thing is once you've got the visual picture of it, now I can figure out what to do. And as they move along, they're probably going to start using the number. If there's 9, I need 11. Well, that's 2 more, so 2 more dogs came into the park. Another child might have said, oh, it's 11. I don't know, how can I say that as a subtraction? I take away the 9 that I have, I would need 2 more. This sentence here is also going to be required. For quite a while, they'll be given it like this, but by the end of the year, they're going to be expected to be able to read a problem and pull out what their answer ought to be. I mean, it's usually 2 dogs, 3 reptiles. But we do want them knowing that it's not this standalone number. It refers back to the problem they were solving. Could you go? No, what? Yeah, let's look at number 4. 16 strawberries in a basket. Go ahead and draw 16. Peter eats 8 of them. What am I going to do?
Cross out 8.
Cross out 8. So now I have Peter. This is Julio. I want to know how many there are for Julio. My total was 16. Peter had 8, and then Julio would have 1. So the tape diagram again, all it is doing is drawing the representation of the meaning of the story. Could you go ahead and do number 5? What should I draw? Excuse me. How many? Yeah, but okay, that would be the answer. And this becomes the, especially with kids who can see it in their head, it's like, no, you actually have to draw the understanding of the problem, not get the answer and then draw it. What's going to be in the first part of my?
Question mark.
Yeah, I personally would do a question mark, because I don't know how many. And then I would do 14. And I have a total of 18. quickly kids are going to start writing these numbers in. How many are they going to need? They're going to need 4 yellow beads. But as they're start using this is a much more complicated problem, obviously, than 1. But as they're understanding the problems and knowing how to represent them in the tape diagram, they don't try to figure it out, they try to represent the problem. Then they're able to figure out the answer. Does this make sense?
Is there a reason why you make unknown first, or does it matter?
Because I'm very literal.
So it's the first
To
one
me, it
first.
said some yellows first. If a child did it the other way, does it make any difference? No. They still represented what the problem meant.
And would they use the number then?
They could. So they might have done this. Again, I do it this direction.
Move it up a little.
Oops, yep.
Thank you.
Now what I would say, if a child is ready to move on, I would start pointing out, look at the relationship here. Look at, we have our total, we have our part, we have our part. But until a child's able to see the relationship between the two, I would have them do both. A lot of tape diagrams are for understanding the problem, not necessarily for solving them. But at first grade, the level of math is such that it can work. In 5th grade, you do the tape diagram, and sometimes you have to do the multiplication in a computation on the outside, but you now understand what you're doing. Yes?
On the very first one, you circled 10, which usually showed that there were 3 left and got you to 13. Is that a necessary step?
No.
Okay.
What will happen, there will be some uses of drawing 10s. All of this is the progression. That would be for a child who's just struggling to count them. At the beginning, they may be having them doing them in different colors. That's going to vary a little bit by teacher. Some of them, at some point, when we start adding all these colors and things, then it starts becoming step by step, and it starts becoming, oh, do I remember the step? And that's not what we want to do. I would say what I did there was I was thinking of, it's the beginning, they're just seeing it. I've got that. The rectangle is new to them. I don't want them to think that the rectangle is this. Yeah.
Right now they do in the first grade, at least the way my son does it in his class, they read the problem, right? And then they have to do his spelling marks. And then he makes a number bond and then a number sentence. So do you suggest that we move from number bond?
I do not suggest that you take your child from number bonds.
From tiny marks into the print diagrams.
I think this is later in the unit.
Okay.
So I think that with the tally marks, they're still ensuring that they're just doing the counting. And that, as I said, we're moving through a lot quicker, so they just haven't gotten to this section yet. This is a more advanced knowledge.
They will move from tally marks into the print diagrams.
Yeah. Yeah, at this point, as I said, the tape diagram is more about comprehending what to do in the problem. What they may then go do to solve it can be many things. I mean, it could still be back to the manipulatives. It could be the tally marks. What you'll see is they'll progress through. But if they don't understand the problem, they can't even start solving it. And the typical thing is most children have been taught to look at this problem. They won't read it. They'll say, oh, there's a 7 and a 6. I'm going to add them. Well, they're going to come down here, and they'll, they see a 16 and 8. I'm going to add them. In 4th grade, they multiply it. So what we're trying to teach them to do is no. There's a story here, and you have to pay attention to it, and you can represent it. If you don't know what to do, representing it that's that step of the problem solving.
One, so here it says that you write the numbers and then for 3 and 4, does 11 minus 9 equal 2? Or if you write 9 plus 2 equals 11, does it make a difference in terms of answering it? Or
No, it all depends on what you did in your head or how you solved it with your students. Sorry, I didn't read my own instructions. RDW is a phrase that you'll get used to. It's read it, draw it, write it. I did not follow my own instructions and write this. So this would have ended up as 6 plus 7 equals 13. That was the big question. Down here, I did it as 9 plus 2 equals 11. Somebody else may have seen it as 11 minus 9 equals 2. And this is where we start having them circle or let us know what was the unknown. But they let us know right down here. So they wrote the math back, but they did tell us what they figured out. So, manipulatives have been put away. We're breaking apart numbers to understand them. So this is about the last place we go. Check. Yeah. With the adding here. So they're understanding how to break apart numbers. They understand how to draw word problems. Now we're getting into bigger numbers and how can we help ourselves. We're going to, my guess is that the teachers are going to say, always decompose the smaller of the two numbers. It doesn't matter, but usually we're taking apart the smaller numbers just easier. So this goes from, we have 18 plus 14. Let me do that in the same color. If we had 14, how would we break that apart into a 10 and a 1? It's the 10 and 4. I can now do, because we've been practicing, remember I said at the beginning, the plus 10s, you should know these by now. So 18 plus 10 equals 28. I'm adding one more 10 to the 110. It's two 10s and nothing to the 1, so it's 28. Now what am I doing? I've taken care of that 10. Now I have to add the 4. 28 plus 4 equals 32. In this particular problem, they still stuck with decomposing the smaller number. It happens to be first. There is no rule about which one you're doing and whether it comes first or second. So it's the same thing. 17 plus 10 is 27. For kids who are getting lost, I have them make a check mark. 27 plus 4 equals 31. I've taken care of it. And I'm writing these numbers up here. And then we do a lot of practice with asking them what's missing to make sure that they're understanding these parts. Yes? The arrow method would come next. Yeah. If you've got a child, so the arrow method would now be 18 plus 14. I now can hold that decomposition of 14 in my head, so I can do 18 plus 10 is 28, plus 4 is 32. So yes, that's the next part of the progression. Can I do one more thing? What we're really not teaching is this algorithm of 4 plus 8 equals 12. In the olden age, we'd probably carry it above. We're now asking them to do it below, and it equals 32. Because this shouldn't be an overly paper pencil problem. There should be ways of thinking it through without having to go to an algorithm. Will we teach them how to do that next year? Yeah.
What about when you do 20 plus 4? Where's the count? Like 29. And is that how it was, or maybe?
Well, what's going to happen, and this would probably be in the next unit. Let me see where this is. Can you tell I'm starting something new here? What we're going to do is start showing them that we can be picky about how we decompose this. Now, this is not this unit. This is answering a question. What if I broke this into 2 and 12? 18 plus 2 is 20. Plus 12 is 32. So then we start having them make choices about how they're decomposing. Right now, we're still in a place value unit. I would expose some kids to this, but not very many, and we'd be starting with lower numbers to begin with. This is bad. I don't quite remember whether they've already done that. Can't think of an example of where they may have already done that. So that's a sneak preview into where they'll go next.
So if it was a 20, and then you then you can do what you have. If you do that, then you have just 20 plus a 10. Then you have.
And because they're able to think it through, this is where we're trying to get these calculations, them understanding it, and it really is mental math. It doesn't take out, everything doesn't become writing it down in a column addition. Yes?
Is it okay to decompose both numbers and we do 10? So like 10 plus 10 and 4 plus 8, for example.
That's okay. You know what I'll kind of tell you? They're getting the right answer and they're needing to see this, like this. Anything's okay. Would we try to move them along to only decomposing 1? Yes. But to begin with, they could definitely do 10 plus 10 is 20, plus 9 is 29, plus 5 is, up to, is that 34? This is where I start making my own errors. Absolutely. And I'm trying to think, I didn't really see it. You may see that coming home first. I don't know. I have misgivings of whether that's easier or not. I think for some kids, it's actually an added step, and I think for other kids, they need to see it. Yes?
We're in, I don't know if we're all in year 1 yet, but we get like IXL homework on an iPad or a computer. I feel like it doesn't practice the kids' handwriting, and it's also timed and maybe a different form of pressure, but also that they can't break things down. I mean, I get my daughter to do it on a piece of paper, but what's your feeling about that?
Without throwing my teachers under the bus, obviously I would just throw them under the bus.
Yeah.
I'm not a big proponent of IXL.
Okay.
I think it's quite good for your math facts, like, up to 10. I don't. I think they should be playing the games where the 2 little fish are swimming by and you have to make them add up to 5. I think putting a fun component, IXL has that timed issue. It also has where it takes away points, which just
and
devastates
also
kids.
It gets the better you do, the harder it gets.
Yeah.
And some of that stuff hasn't been covered.
Right.
So it gets frustrating towards the end. It doesn't usually happen, but there's certain ones that then it's like kind of above their skill level, I guess.
Right. And I would.
Do you have
I would
any-
hope it really should be about practicing for 10 minutes,
Okay.
not finishing a session,
Okay.
because for a child, one session may be
Well,
2 hours because of those last 2 questions they're missing.
Well, and reading the word problems, I think it's a lot of
Yeah.
reading so it takes about half an hour, like for my daughter, it's about half an hour, it's no problem.
I'll have a chat. I mean, some of it is they are just trying to give more practice. I have some issues that IXL still does a lot of things very traditionally. To be fair to them, they have tried to improve, and I don't go onto their website at every grade level often enough to see how they've improved.
Okay.
But I'm not so sure I was aware that IXL was being given. And, it's not horrible. I think for some kids, I've watched them come back in tears. We've just failed. That was not the intention. So I recognize a lot of faces, but I am going to do my soapbox. Absolutely every brain can learn math, with very, very, very few exceptions. Some of us just take longer, some of us just need to see it differently, but we all get there. Math, so for all of you, you cannot be saying or giving any sort of implication that I'm not good at math, because if you're saying that about yourself, then your child can go, oh, me neither, and think they're done. It is a lot about the effort. There's a lot about having a growth mindset, and effort is everything. Not quite everything. It has to be effort in the right direction. Mistakes are good as long as we look at them and see what went wrong. The brain research does show your brain is growing more when you're making mistakes, but not if you just make a mistake and keep going. You have to look at it, you have to be aware that you made a mistake, and you have to try to figure out how to do it. Working with your child on one problem where they've made a mistake and you get through to the right answer is definitely better for that child than doing 20 minutes of them right. If your child is doing 20 minutes of it right like that, it's a waste of their time. They're not learning anything. They already know how to do it. That's okay in 6th grade. We're building those pathways to the long-term brain memory, but don't, anytime you're working with your child, if you start getting frustrated, stop. Both of you, stand up, walk around the table, go get something to eat, come back to it. We don't mean give up, but frustration, literally your brain, the chemicals in it shrink back down when you get frustrated or there's tears. It's amazing how much a smile can do. It breaks the tension. Put the pencil down and go, yep, it's hard. Okay, do we want to tackle it? With your proper attitude, your child is going to want to tackle the problem. So this has to be about a positive attitude. And it's not just math, it's reading, it's everything. It's about, in my household, it would have been about eating the silly peas. But it is about attitude and being willing to do the effort. Yeah.
The first one is IXL or something like that, but I thought it has to do with grade 4 mathematics. Because I know some teachers online. Does the library have a list of books which are maths, like stories that have maths?
I think they're all in the same section. I don't know not ISBN numbers. I don't know their call letters, but the librarians would. Like, we definitely have them. Yeah.
And my third question is, could you tell us like a timeline, like when are the kids doing take programs? When are they going to start doing? Like, is this over the rest?
It's
of
in
the
this
year?
unit.
So is this unit over the rest, spread out over the rest of the year? Or
No, it's probably got about 4 weeks more.
4 weeks?
Yeah, I can't say exactly where it is. What I did for you was fairly in order of how the unit goes, except that, as I said, your last 2 pages are the comparing of value of the 2 numbers. I knew I wouldn't have time to go through this. I wanted to show you what they were doing, but I'm pretty sure they're pretty self-explanatory. But it gives you an idea and a way to see them. I think there's also a mistake. This was interesting. This is not my mistake. I copied this. I would rearrange those numbers. So this is what you'll be seeing, and this is how they'll be teaching it. I'm quite certain you can figure them out. And the very last page is there's also, well, what can I do for my child? More IXL and that I discourage, but asking the kids, your students, again, such things as 30 equals 3 10s and 0 ones, the 2 10s plus 10 ones, asking them those sort of questions, which can be done at the stoplight at Alveston and Alwab. That was 10 minutes the other night. You could be asking these types of questions, and it should go back and forth. They should be allowed to ask you. How many 10s and 1s are there in 24? What's another way of doing it? What's another way of doing it? Because that's that flexibility of understanding numbers. So that's a big one in this unit, is understanding those 10s and 1s. And then defending it. Can they explain? You say that 24 is 1 10 and 14 1s. Why? Well, because I know in the 14 there really is a 10. I mean, can they explain it in words? Any other questions?
What more than
Yeah, I mean, I want them to know both. So, I mean, it's really, this unit only goes up to 40, so don't give them 120. But if you gave them the number 36, how many different ways could you make that? And that's where they start understanding that addition, I mean, because one, they could go to, if it was 36, they could say 3 10s and 6 1s. Well, that is 30 plus 6. So it's getting that relationship of the place value to an addition. If my child said, well, it's 39 minus 3, I would be jumping up and down for joy if they were doing that mentally. So we're not getting real picky. We're just getting that they're playing with the numbers and seeing them many different ways. I do have a review sheet, just wanting to know, is this helping you? I realize you're not mastering it either. You've already mastered the math. But the strategies are new. the goal of this is, can you help your child? These sessions are mostly for number sense units. I think the one coming up after this is going to be shapes or geometry, so I don't do that. There will be one more, at least one more before the end of the year. But by now, it's really the same ideas circling at a higher and higher level, so not higher level, larger numbers. I didn't realize that my new site looked so boring. This is the site that I was mentioning to you that is on the front. If you come here, you can go to grade 1. We're in unit 3. Under unit 3, it says the parent workshop path. Well, it'll come up. Is your workshop, your worksheets, and then there's the worksheets with the answers. So this is the idea of what will be up on there. When I understand how to put the videos up, a video of today will be up there and a video of the last one, so that if you missed something or wanted to see it, it would be. Thank you for coming. Be glad to answer any other questions if you have them.